Welcome back to chemical technology. Last time we have discussed about the rubber industry and the other industries related to that one. So in coming modules we will try to discuss about the petroleum industry and the mainly we will focus on the petroleum processing with respect to chemical technology. As we have seen, the petrol is one of the important substance or the petroleum products which are the one of the important substance of our day-to-day life, and the as India is lack in the petroleum the sources, we have to import the petroleum from other countries. That's why the petroleum is the major governing factor for our Indian economics. So as far as the city is concerned, we will mainly focus on the petroleum processing rather than the chemistry of the petroleum. So in the coming modules, we will discuss what are the different processes that we require in petroleum refining. So the refining processes such as the hydrocracking, then desulfurization, then distillation. So these kind of processes we will discuss in the petroleum industry. So petroleum processing industry, it is very complicated one, and there are various kind of products like the petrol, diesel, gasoline and other polymers that we get through the petroleum industry. So in module we will try to see the introduction to the petroleum processing industry. Then there are two kinds of process, that thermal and physical, and also the catalytic processes using catalyst. So the physical process, then we will see the thermal processes, then catalytic processes, then conversion of heavy residues, and finally the treatment of refinery gas streams. So the coming to the introduction, we will see the oil refining is the key activity in the chemical technology. Then the petroleum is one of the key product where serves the major. So over 600 refineries worldwide have a total annual capacity of more than 3,500 into 10 to 6 tons. And the goal of oil refining is twofold. So it will include the production of fuels for transportation like petrol and diesel, then power generation and heating. So the power generation is mainly by burning the petroleum products, and heating is required in the colder countries, and the production of raw material for the chemical technology. Then oil refineries are complex plants but are relatively mature and highly integrated. So today technology is increased so that we can handle very heavy crudes, and we can have the more products from the oil refinery. So if we see the crude oil, then if we see the carbon to hydrogen atomic ratio, then methane is very less whereas the coal is very high. So if we can see the petroleum or the crude oils, they will have around 0.5 to 1 carbon to hydrogen ratio. So the carbon to hydrogen ratio is required, or we should consider for this energy property. Then next comes the constituents of the petroleum. So generally in petroleum the majority of crude oil is alkanes, then cycloalkanes like naphthenes, then we have the aromatics, polycyclic aromatics, then sulfur containing compounds. So gasoline, or we say petrol, it mainly consists of branch alkanes, and the diesel where mainly we have the linear alkanes. So alkanes, we have the normal alkanes and branch alkanes. The aromatic, they will have the benzene ring. So depend upon the number of benzene rings, they are further divided. So like we have the alkyl benzenes, then aromatic cycloalkanes, then the fluorines, then binuclear aromatics. So different kinds of the product, mainly aromatic and non-aromatic, that is aliphatic. So this will present in the crude oil. So if we see the heavier crude oil, that means we will have the higher molecular weight and more cyclic or the polycyclic polynuclear aromatic compound that we will find in the crude oil. So if we take an example, so they are phenanthrene, the pyrene, the cresene. So the heavier crude contains more polycyclic aromatics, and it will lead to the carbonaceous deposit called coke after burning. So when we burn petroleum, the black soot that remains behind, so that will be termed as the coke in the petroleum industry. Then some crudes contain a lot of sulfur which leads to processing consideration. So sulfur is one of the content that we generally don't require, and generally the process are done to remove the sulfur from the petroleum. So the sulfur containing the main are the hydrogen sulfide, which is a gas which we can remove easily, but others like the cyclic or disulfide or the substituted dibenzothiophene, so that is difficult to remove. So generally these are required in heterodesulfurization process, where we are using the hydrogen to burn the sulfur, and the final product that comes out is the hydrogen sulfide, which contains the sulfur which is removed from the crude oil. Then if we see the overview of the petroleum industry, so after desalting and dehydration, crude is separated into fractions by distillation, and the distillate fractions cannot be used directly. So the reason for such a complex setup process is the difference between crude oil properties and the needs of the market. Then another reason for complexity is environmental. Legislation demands cleaner products and is the major drive for process improvement and development of novel processes. So desalting, where we remove the salt by filtration, and dehydration, removing the water. Then we separate into the fractions by distillation. So we will see the distillation. What does it mean? So the product should be manufactured so that it will have a good demand in market, and it should be sellable in the market. So to achieve that one, the different processes are adopted, which will make the crude oil more adaptable to market conditions. So in the refining operations, so petroleum refining processes and operation can be separated into 5 basic areas. So one being the fractionation or the distillation. So here it is the separation of crude oil in atmospheric and vacuum distillation towers into group of hydrocarbon compounds of differing boiling points, ranges called fractions or cut. So fractionation or distillation, where the crude oil which comes will separate into the different the categories or boiling point ranges, generally as petrol, diesel, kerosene, naphtha. So this will be termed as fractions or the cuts. The next being the conversion processes. So here it will have the change the size or the structure of hydrocarbon molecules. So these processes include the decomposition or dividing by thermal and catalytic cracking, then unification, the combining through alkylation and polymerization, and the alteration or the rearranging with isomerization and catalytic reforming. Then the treatment processes to prepare hydrocarbon stream for additional processing and to prepare finished products. So treatment may include the removal of separation of aromatics and naphthenes, then impurities and undesirable contaminants. The treatment may involve chemical or physical separation like dissolving or absorption or precipitation using a variety of combination of processes including desalting, drying, hydrodesulfurizing, solvent refining, sweetening, solvent extraction and solvent deraxing. So here the things are the fractionation, then conversion and the final treatment or the finishing process. So in finishing, the desalting, drying, then hydrodesulfurizing, then solvent refining, sweetening and solvent extraction and the solvent deraxing. So these are the refining operations that we will discuss in detail in the further slides. So in a refining operation, the things come is the next thing comes is the formulating and bending. So after the treatment process, what are the products which are getting, we are formulating and then bending. So it is a process of mixing and combining hydrocarbon fractions, additives and other components to produce finished products with specific performance properties. Then other refining operations include the light ends recovery, then sour water stripping. So sour generally were used for the sulfur content. Then solid waste, then process water and wastewater treatment, and cooling, storage and handling and product movement, then hydrogen production, acid and tail gas treatment, and the last one is the sulfur recovery. And next things comes in the refining operation, that the auxiliary operation and facilities include the light, steam and power generation, the process and fire water systems, flares and relief system, furnaces and heaters, then pump and valves, and supply of steam, air, nitrogen and other plant gases, then alarms and sensors, noise and pollution controls, sampling, testing and inspecting and laboratory, the control room, maintenance and the administrative facilities. If you see the modern refinery, so the flow scheme of a modern refining, so here if you see the crude oil, so first it has to go through distillation. So we have the atmospheric distillation and vacuum distillation. Then we can see the different varieties of products that comes, and lastly we are doing the treating and blending. And if you see the last one, then we'll have the fuel gases, LPG, gasoline, then kerosene, diesel, then greases that we normally know. So the refinery is very complex structure where the raw material is one, crude oil, but the outcome or outcoming products that are very various. So it is the one of the simple scheme shown over here for the refinery. The flow scheme may become very complex depend upon the crude oil composition. And if the crude oil is of not quality, then many other processes they have to include in order to purify it and to get the good products of our desired demand. So there are different chemical and physical processes. So physical process mainly will involve distillation, solvent extraction, then propellant desulfating, solvent reaction and building. Whereas chemical we can further divide into thermal and catalytic. So thermal it will be vis breaking, then delayed coking, flexi coking. In catalytic we will have the hydrotreating, catalytic reforming, catalytic cracking, hydrocracking, then catalytic dewaxing, alkylation, then polymerization and isomerization. So physical process that will include the distillation. So here we have the desalting and dehydration, distillation, then crude distillation, propellant desulfating, solvent extraction and blending that we have seen. So in this one, distillation is the major that we have to discuss in detail. As far as the desalting and dehydration is considered, so crude oil often contains water, inorganic salt, suspended solids, and water soluble trace matter. So step 1 involves step 1 in the refining process is to remove these contaminants so as to reduce corrosion due to the salts, then plugging and fouling of equipment, and to prevent poisoning catalysts in the processing units. In the two most typical methods of crude oil desalting are chemical and electrolytic precipitation, and both use hot water as the extraction agents. So most of the chemicals they are water soluble, so we can remove with the help of water, and if they are ionized we can use electrolytic separation to separate them. So in chemical desalting, water and chemical surfactants like deemulsifiers are added to the crude, which is heated so that salts and other impurities dissolve or attach to the water and then held in a tank to settle out. Then the electrical desalting is the application of high voltage electrostatic charges to concentrate suspended water globules in the bottoms of the settling tank. So generally surfactants are added only when the crude has a large amount of suspended solids. So desalting and dehydration is prior to the distillation, where the salts and solids and the other water soluble trace metals they are removed, and it is removed by some physical methods in order to avoid the problem in the next. And the third and rare process filter hot crude using the diatomaceous earth to remove the suspended ones. Then we have the operation which will heat the crude oil feedstock around 65 to 180 degrees centigrade in order to reduce the viscosity and the surface tension for easier mixing and separation of the water. The temperature is limited by vapor pressure of the crude oil of feedstock. So suppose if crude oil is of higher viscosity, then in order to reduce viscosity we can heat up to the higher temperature, and it will reduce the viscosity. That will make the mixing operation easy. In both methods other chemicals may be added, like the ammonia in always added to remove the corrosion. Then caustic or acid may be added to reduce the pH of the water wash. So if we see over here, then unrepared crude and the water it will come. So it is heated previously in order to lower down the viscosity. Then emulsifiers are added, and then it will go to the gravity settlers where water and the crude oil it will be settled. Then water will go to the plant where the desalted water will go. So here you can see the pictures of the gravity tank settlers. So these are the round cylindrical in which we allow the crude oil and other impurity to settle. So they will separate by means of their physical gravity differences, and we can get the crude water. The next step in the refining comes is the distillation. So distillation is done after refining. So it is defined as a process in which a liquid or a vapor mixture of two or more substances is separated into its component fractions of desired purity by the application and removal of heat. So distillation you are very familiar with. So if you heat something, it will go into the vapor phase, and that vapor when we cool down will get the water. So generally it is done to purify the water. If water contains some salt impurities, we will heat it. So only the water that will be evaporated. The salt and other compounds being very high boiling point, so they will not evaporate at this temperature around 100. So water will be effectively evaporated, and then we have the condenser in which we will remove the heat from it, and then again it will convert to water, and the water will be free of the salts. So this is one of the purification technique that we have learned in the science. So the same principles we will use in order to refining the crudes, but the process here will be more advanced than the discussed one. So distillation is based on the fact that the vapor of a boiling mixture will be richer in the component that have the lower boiling points. So when we are heating the mixture, the component which is of lower boiling point, it will be evaporated first, and the component with higher boiling point, it will be remain in the bottom phase. So thus when this vapor is cooled and condensed, the condensate will contain the more volatile components. At the same time, the original mixture will contain more of the less volatile components. So the bottom product that will be remain less in the volatile, whereas the upper one which will be more in the volatile components. So distillation is the most common separation technique, and it consumes enormous amount of energy both in terms of cooling and heating. So in this one we have to do the heating also, and we have to do the cooling also. So the major energy, or around the 50% of the plant operating cost, is done on the distillation part. And distillation columns are classified by the manner in which they are operated. So we will discuss what they actually are. So they are the batch wise, in which the feed of the column is introduced batch wise. That is, the column is charged with a batch, and then distillation process carried out. When the desired task is achieved, a next batch of feed is introduced. So in batch 1 we will get the material at once, we will have the distillation, and then we will separate the components. Whereas in the continuous process, the continuous column process a continuous feed stream. No interruptions occur unless there is a problem with column or surrounding process units. They are capable of handling high throughputs and are the most common of two types. So here the batch it will have the feed at once, whereas the continuous it will have the continuous feeding, but the product volume will be higher in the continuous, whereas it will be lower in the batch distillation. So the most of the operation now is based on the continuous, because they will handle the large volume at one time. So they will be classified into the nature of feed that they are processing. Like binary column when mixture is of two components, and the multi-component columns when we have the more than two components to be separated through the distillation. Then number of product streams they have, like multi-product column has more than two product streams, where extra feed exists when used to help with the separation. So they will have the extractive and azeotropic. So extractive distillation, where the extra feed appears in the bottom product stream, and whereas the azeotropic distillation, where the extra feed appears at the top product stream. So extractive, we are adding another product which will extract this other component effectively, and it will alter the boiling point. So generally in extractive distillation, the extra feed appears in the bottom, whereas azeotropic, we will mixture the azeotropic boiling mixture Generally, it will reduce the boiling point and it will appear at the top product stream. Then it depends upon the type of column internals. Then we'll have the tray column, where the trays of various designs used to hold up the liquid to provide better contact between vapor and liquid, whereas the pack column, packing are used to enhance vapor liquid contact. So here if you see the diagram, then it shows the typical the refining the distillation column. So the vertical chair, it is vertical shell where separation of liquid components is done. Then we have the column internals. The examples are trays or plates or the packing, which are used to enhance the components separations. Then we have the reboiler to provide the necessary vaporization for the distillation process. Then the condenser to cool and condense the vapor leaving the top of the column. Then we'll have the reflux drum to hold condensed vapor from the top of the column so that liquid can be resolved back to the column. So if you see the tower, here you can see the liquid will come, then feed is feeded from the middle of the column. So reboiler will boil it in order to make it continuously boiling. So the lower volatile, it will go up in the vapor phase. So it is condensed into the condenser and will get the liquid. Then we will check of the composition. If composition is of not desired quality, then we will again send back to the column. So this reflux operation is taking place. So if the product gets of desired quality, then we can take it out through the distillation. Then in this one, trays and plates are used in the column. So bubble cap trays, a riser of chimney is fitted over each hole and the cap covers the riser. The cap is mounted with a space to allow vapor to rise to the chimney and can be directed downward by the cap. The final discharging through slots in the cap and bubbling through the liquid on the tray. So in this one, the vapor will come up. So it's like the whistle on the pressure cooker where the vapor will lift it up. So in this one, the vapor will lift the cap and the most volatile component will remain in vapor, and suppose any component is mixing which is of higher boiling point, so it will again convert it back to the liquid and it will come down again. So it is done to ensure that the vapor will have more or more volatile component, whereas the bottom will have the higher boiling component. So in this one, the vapor is the key which lifts the cap up, and the liquid from the higher boiling point, it will again trap and it will come down again. And another, we have the wall trays. The perforations are covered by caps lifted by vapor, which creates a flow area and directs the vapor horizontally into the liquid. Then we have the sieve trays. So they are simply metal plates with holes in them. The vapor passes straight upward through the liquid or on the plate. The arrangement, number and the size of holes are design parameters in this one. So if we see the design, then we can see the vapor is moving up whereas liquid is coming down. So here the most volatile component, it will push up and it will be, we can find in upper stream, whereas the most volatile, it will come down. So the tray area, active tray area, it will serve as a barrier and it will not allow the higher boiling liquid to go up. So it is generally done to separate the higher boiling point and the lower boiling time mixture completely. So it will ensure that the vapor is more and more rich in the lower boiling point mixture, whereas the downward will have the higher boiling point. Then in next diagram we can see the flow of the liquid. So the vapor will go up and the liquid will come through the sides of the tray. Then liquid and vapor flows in a tray column. So each tray has two conductors called downcomers, one on each side. So liquid falls by gravity through the downcomers from one tray to the tray below. Where ensures there is always some liquid or hold up on the tray and is designed such that the hold up is at a suitable height. It means such that the bubble cap are covered by liquid. When vapor flows up the column and is forced to pass through the liquid via the opening on each tray. The areas allow for the passage of vapor on each tray is called as active tray area. Then the next thing we use is the packing. So as we have seen earlier in fluid mechanics lab, they are using the packings in the fluid flow column and the pack column. So the same kind of packing we are using, and nowadays we have very advanced packing which will give more contact area. So it is better for the effective mass transfer and the good heat transfer between vapor and liquid. So packing are passive devices designed to increase the interfacial area for vapor liquid contact. So they will increase the mass transfer, and they do not cause excessive pressure drop across the pack section, which is important because of a high pressure drop would mean that more energy is required to drive the vapor up distillation column. And then pack columns are called continuous contact columns, while thread columns are stage contact columns because of the manner in which vapor and liquids are contacted. So here in drawings we can see the different type of packings. So the packing may be continuous contact or the stage contacts. So when you see a distillation column, in this one you can find the numerous varieties of packing depend upon the what kind of mass transfer operation we require. So basic operation in this one is the feed is introduced somewhere near the middle of the column to a tray known as feed tray. Then the feed tray divides the column into top enriching or rectification and the bottom stripping. So feed is in the middle, so up portion will be called as the rectifying column, whereas the down one is called as the stripping. The feed flows down the column where it is collecting the reboiler, and heat, usually as a steam, is supplied to the reboiler to generate more and more vapor from the mixture. The vapor from the reboiler is introduced into the unit at the bottom of the column, and the liquid is removed from the reboiler is known as bottom products or simply bottoms. So the vapor which are coming up, that is passed through the condenser in order to liquefy them again, and the liquid which remain in high boiling point at the bottom, so they will be called as the bottoms in the chemical engineering. So here if you see the vapor which is coming up, so it will pass through the condenser and it will go in the reflex drum. So ratio is checked, and if ratio is fine, then we can take it out, otherwise we will reflex it. So the vapor moves up the column, exits the top and cool in the condenser. The condensed liquid is stored in holding vessel known as the reflex drum. Some of this liquid is recycled back to the top of the column, and this is called the reflux. The condensed liquid that is removed from the system is known as distillation or the top products. Thus there are internal flows of vapor and liquid within the column, as well as external flows of the feeds and product stream into and out of the column.